Talked about the circle, and now I want to talk about another conic, which is a parabola. Now you're familiar with parabolas from working with quadratics, but I want you to think of parabola in a different sense. A parabola is really a set of points in a plane that are equidistant or the same distance away from a fixed line, which we call a directrix, and a fixed point, which we call a focus, that's not on the line. So let me create this for you with some geometry software. So I'm going to create a point, so this is the focus, and then I'm going to create a line, which is the directrix. Okay. Now what I want to do is make a point on the directrix, and then I'm going to make a segment from the focus to that point. And now I'm going to construct a few things which I'll explain in a minute. So I want a perpendicular line that goes through that point. I want the midpoint of that segment. And then I want to create a perpendicular line to there. And finally, I'd like to get the point where those intersect. That's going to be one of the points on my parabola. That's the same distance away from the focus as it is the directrix. Okay, so now as I move this point along the line, that point is this point right here, I want you to follow the path of that point as I move along the line. And you can probably tell that it's making a parabolic shape. But let me make that even easier for you to see. And let's trace that. And so those are all the points that are the same distance from the focus and the directrix. And the reason that works, let's see if I can do this for you. If I connect there, that makes an isosceles triangle, and in that isosceles triangle, those are the two legs that are equal. So the distance from the point up at the top, the vertex, this point here, straight down, perpendicular to the directrix, that's the distance from the point to the line. And then the distance from the point to the focus is the other leg of my isosceles triangle, which is going to make that equal. So let me hide a few of these. And let me create, let's take this point. And there, I can talk while it's moving now. So it's creating all the points that are the same distance away from the focus and the directrix. And as you can see, as we start filling in more and more points, it takes on that nice curved shape of the parabola that we're familiar with when we worked with quadratics. Okay. So, let's get rid of that. There are four basic orientations for a parabola. So I've separated these into the four different views that you could see. We have a parabola opening upward, and the equation for that is x squared equals 4py. Now that's probably not an equation that you're used to. We're used to writing something like y equal x squared, or y equals ax squared plus bx plus c. Right? So this form is a little different, and you're going to have to get used to that form. So for each of these pictures, you can see the one below, down here, we have x squared equals negative 4py. And then over here, that's a y squared equals 4px. Or if it's opening to the left, we have y squared equals negative 4px. Now for all these pictures, we have the vertex of the parabola is at the origin. If that's not the case, then if it's shifted and the vertex is at the point h comma k, then this becomes our equation. And likewise for each of the other different orientations as well. Okay, and that shouldn't be too unfamiliar, especially after working with circles. Now, so we have the standard form, which is this new form that you're probably not familiar with. And from working with quadratics, you're more used to writing it as in the quadratic form, or vertex form, sometimes it's referred to as the vertex form for a parabola, which we talked about last semester. Okay, so we're going to focus on the standard form. So let's talk about some of the terminology. So we have our directrix and our focus. So there's some other important information when we have a picture of a parabola. First of all, if I make a segment which goes through the focus that's parallel to the directrix, right there, that's called a focal chord. Focal chord. That term usually doesn't come up too much, but in case you do see it, that's what we're talking about, the focal chord. Now, remember in the equation we had x squared equals 4py, for example. And this, what does this p represent? Well, it turns out that the length of the focal chord is 4p. So it's 2p from the focus to either side of the parabola. Now likewise, if we drew another segment that went through the focus perpendicular to the directrix, well, if it keeps going, if it's a line, that's called the axis, or axis of symmetry. And we've talked about that before as well. But from the focus, the segment that's perpendicular to the directrix, it hits the parabola at a point which we know as the vertex. And so it turns out that the distance from the focus to the vertex is p, or 1p, and from the vertex to the directrix is also 1p. And just to help you see, let's go green, why that's true, if from the focus to one side of the parabola is 2p, and then this distance is also 2p. So this point is the same distance to the focus as it is the directrix, which is why we have 1p and 1p between the focus, vertex, and the directrix. Alright, let's get rid of that. Alright, so there's the terminology, and this visual should help explain what p represents in your equations. Alright, so now let's do a few practice problems. Find the standard form of the equation of the parabola with the vertex at the origin and focus at 0, 4. Now, I highly recommend, it's a good idea always to draw a quick picture, just to give you an idea of what you're looking at. So, the focus is at 0, 4. So let's put that in red. 0, 4 is right about there. And the vertex is at the origin. So you know that this is the way it has to go. So out of those 4 pictures that I showed you a few minutes ago, you have to decide which of the 4 pictures are we dealing with. And so for this picture, what was the equation? It was x minus h squared equals 4p times y minus k. Okay, so h comma k is the vertex, and in this case it's 0, 0. So we have to figure out what p is. Now remember, the distance from the focus to the vertex is 1p. So since your focus is at 0, 4 and your vertex is at 0, 0, that tells me that p is equal to 4. So now I'm ready to go ahead and write the equation. So it's x minus 0 squared, or just x squared, equals 4 times p, which is also 4, times y minus 0. So in other words, x squared equals 16y is the standard form for the equation of this parabola. All right, let's look at another example. This time I'm going to give you the equation and I want you to find the focus. So we know how to find the vertex. When we had a shortcut, we did x equals negative b over 2a. But that's not what we're looking for here. We're looking for the focus, which, when you graph this, just graphing any old parabola, the focus is somewhere here. So we have to figure out where the vertex is and what p is, and then we can figure out where the focus is. So there's a couple ways that we can deal with this equation. We're going to need to complete this. So the x is the term that is squared. So we know that it's opening upward or downward. And we need to complete the square. And so one of the ways we completed the square was we factored out the coefficient of x from the x squared and the x term. But in this case, sometimes that's a little difficult to do. So instead of trying to do that, I'm going to show you an easier way to deal with this. First thing I would do is let's try and get rid of all the fractions. So if I want the x squared to have a coefficient of positive 1, I could multiply everything in this equation by negative 2. Then I'm going to have negative 2y on the left. Negative 1/2 times negative 2 is just positive 1. So I'll have 1x squared, and then plus 2x, and then minus 1. Now I'm going to take this minus 1 and move it over to the other side. So I have negative 2y plus 1 equals x squared plus 2x. Now I'm ready to complete the square on the right side. So remember, we look at this coefficient, divide it by 2 and square it. So that's going to become a plus 1 to make that a perfect square. And so I have to also add 1 to the other side as well. So now what I have is negative 2y plus 2 on the left. And I can write the right side as x plus 1 squared. And now if I flip that around a little bit, and I write x plus 1 squared on the left, and I factor out a negative 2 from both terms on the other side, I'm going to have negative 2 y minus 1. And now that's in the form, let me write the form for you. X minus h squared equals 4p, or in this case, negative 4p y minus k. So you really, I can't go back, I'm going to jump back up to there. I can't stress enough, you have to remember these 4 different orientations and what the 4 equations are for each of these graphs. So right now we're looking at this one, because that's what we have, that's what we have for our equation. Let's go back. Okay. So I know that this is going to be looking something like, wherever the vertex is, something like that. Alright, so let's identify our vertex is negative 1, 1, looking at these. Okay. And then negative 4p equals negative 2, by looking at that. So my vertex is at negative 1, 1, and I know that p is equal to negative 2 divided by negative 4, or 1/2. So this is the information that I need. Alright, so now I'm going to draw a little more accurate sketch. So the vertex is at negative 1, positive 1. Right there. And we know that this opens downward. Okay. And we know that p is equal to 1/2. And so the distance from the focus to the vertex is p. So that tells me, since that distance there would be 1/2, and that's what P equals, that's where my focus is at. So the focus, which is what they asked us for in the problem, is going to be at -1, 1/2. Now if I needed to get the equation of the directrix, I could do that as well, because I know if I go P units in the other direction, another 1/2, that'll take me to the directrix. So the directrix in this case would have the equation y equals 1.5 or 3/2. Okay, but all we had to do was find the focus. All right, let's try one more problem. Find the standard form of the equation of the parabola with a vertex there and a focus there. All right, so once again, let's go ahead and we'll map this out. 3, 2. So that's our vertex. And then we have focus at 1, 2. Right there. Now go back and look at those 4 pictures for the parabola. Jump back here. In these pictures I didn't put the focus, but in each, well, it's right there. Focus is going to be right about there, and right about there. Okay? So we have to decide which one of these are we looking at. The red, and actually I think I just did them backwards for you. Sorry about that. But in this picture, the red was the vertex and the blue is the focus. Here, I won't confuse you, I'll make it easier. There you go. So now the vertex is in blue and the focus is in red. So go back over here, and that looks like this one. So you know that your equation is going to be y squared equals -4px. All right. And if we move our vertex around, it's going to be y minus k squared equals -4p x minus h. There we go. If you want to be more accurate, you can always figure out the intercepts later. All right, so we have to find the standard form of the equation. So I think we're almost ready to go. We just need to figure out what p is. So first of all, the vertex was 3, 2, so h is going to be 3, k is going to be 2, and then the distance from the focus to the vertex in this case is 2, and that's the value of p. So we know that p is equal to 2. So now we can write the answer to our problem. So that's going to be y minus 2 squared equals -4 times 2 times x minus 3. So final answer, y minus 2 quantity squared equals -8 x minus 3. It takes a little practice, and I have some problems for you in a minute. But once you get the hang of it and you remember what those 4 different orientations are, then it becomes pretty easy. One other question for you on this problem. What's the equation of the directrix? So where would the directrix be in this picture? Well, the directrix is going to be somewhere over here. It's a vertical line, so it has the equation x equals, and we know that the distance from the vertex to the focus should be the same as the distance from the vertex to the directrix, so p units as well, so that would be 2 units over, which would take us over to 3, 4, x equals 5. So the directrix has the equation x equals 5. And there you go. Alright, so here's some problems for you. I'd like you to work on these. Upload them. If it takes more than 1 page, please remember to try and put them all in one document and make sure you send it or upload each of the individual pictures but I've had some issues with people. I'm only seeing the last page of their problems. So make sure you upload that correctly. And once again, if you have any questions, shoot me an email, and I hope that everything's going well for you. Bye.